Hello everyone, welcome to the chapter of Python, and there's a disclaimer here that the Python that I'm going to talk about is only meant for data engineering, and this is going to be the agenda. What is Python? I'll talk about various popular Python libraries. Then I'll show you the installation of Python. Basically, how can you install Python using the download link provided by python.org, and you can do the installation in Mac or Windows or Linux machines also. Then I'm going to talk about some IDEs or integrated development environment like PyCharm and VS Code. By the way, I'll be using PyCharm for the entire Python course. If you want, you can use VS Code also, which is Visual Studio Code. These are more or less similar. Then I'll talk about virtual environment, and finally I'll discuss Python architecture, and then I'll conclude this section. There are certain prerequisites. One of the prerequisites is that you have to install Python. It's better if you install the latest version. As of now, as of this recording, the latest version is 3.15, but I'm using 3.12. Then you can install PyCharm Community Edition. Do not install the Professional Edition, because if you install Professional Edition, you'll have to buy the license. So install the PyCharm Community Edition, and that will be more than enough for our hands-on. In fact, that will be more than enough for you to do any work on Python also in production environment. Now, of course, the question is why Python? Why should we even learn Python? There are other programming languages like Java, .NET, JavaScript, etc. Golang is also there, but why should we learn Python? The first thing is it is very easy to learn. As usual, as it is easy to learn, it is easy to write and understand also. So it will not take you too much of time to understand Python and then start coding using Python programming language. So that's why the adoption of Python is very huge. Python is used by web developers to backend developers to data scientists, data engineers, and database developers also. Now, it is mainly used in data engineering. In fact, it is used extensively in data engineering. It is also used extensively in artificial intelligence and machine learning, which is AI/ML. And there are a lot of machine learning libraries that use Python extensively, which have created libraries only for Python and R programming language. So Python is one of the go-to languages for creating machine learning models or creating machine learning codes. Now, there is a link between data engineering and machine learning. So in data engineering, we start with databases and we end with consumption layer, wherein we store the data in data warehouses or data lakes or data lakehouse, and from there can be a consumption layer, and we can have Power BI, MicroStrategy, Click, Tableau, etc. BI tools which read data from that final layer. But that is actually the starting of machine learning pipeline. So what happens is that the data that we process, the data that goes through the entire data engineering pipeline and finally cleansed and stored, that becomes an input to machine learning. And the first stage, in fact, one of the first stages of machine learning pipeline is data pre-processing. To pre-process a data, you have to make sure that your data is perfectly clean. So that's why machine learning is a natural progression of data engineering. So if you know Python, you can work both on data engineering and you can do programming and create models in machine learning or create machine learning models using Python libraries. It is used in data science also. A lot of data scientists use Python because it goes back to the first point that it is very easy to learn and understand. It does not take too much of time for you to understand a Python code or understand the entire Python ecosystem and write code, whereas it might be very difficult for a non-coder or a non-developer to learn Java or .NET or any other programming language. Python is relatively much easier. It not only stops in the data and ML ecosystem, Python can also be used in web development, automation and scripting. So when I say web development, Python can be used to create microservices, backend programs, etc. And we can use Python for automation of cloud environments, automation of various other platforms also. For example, AWS provides a library called Boto3, which can be used to call APIs to automate a lot of AWS provisioning. And not only that, GCP also gives library to expose the APIs which are provided by GCP, and we can use Python to to create infrastructure or provision infrastructure in Google Cloud, and for that matter in Azure also. So that's where automation and scripting is another area where Python is used extensively. And as I already mentioned, we can use Python to write microservices for backend development. One of the major reasons for Python to be popular is because of the libraries that it has. As of this recording, Python has more than 525,000 libraries in the Python package index or PyPy. This is basically an official listing of all the libraries that Python has. As of this recording, I think it is 530,000 libraries that Python provides. As I talked about libraries, what are Python libraries? Libraries are actually pre-written code for various domains. For example, for machine learning, we have libraries like scikit-learn, NumPy, etc. Similarly, we can use a library called PySpark to run or to write Spark codes, and this library provides all the APIs that are there in Spark. So we can write Spark code using Python also. So PySpark is basically the Spark library in Python. Similarly, we have a lot of other libraries, and all these are pre-written code that we can use in our code to execute the logic in a particular platform. And these are the most famous libraries in Python. Again, this is definitely not an exhaustive list. So one of the very famous libraries is NumPy, and the full form of NumPy is numerical Python. It is mainly used for mathematical computing, and it is again very useful in machine learning, in creating machine learning models. Similarly, we have pandas rather. Panda is used for data manipulation, and pandas can be used for data processing, and it can be used in machine learning also. Then you have matplotlib, which is used for data visualization. We have library for Spark called PySpark, which is used to write code using the Spark processing framework. Then you have libraries like Flask and Django, which are used for web development and backend development. We can create microservices using Flask. Then we have TensorFlow, which is a very popular library for creating deep learning models. Then you have scikit-learn, which are used to create machine learning models using algorithms like classification, regression, etc. We also have something called SciPy or scientific Python, which is used for scientific computing, and it is typically used by the scientists. Apart from this, there are a lot of other libraries also. For example, a few more which are not related to data. One of them is requests, which is used for HTTP. We have something called Jupyter, and we'll talk about Jupyter in EMR, in Glue, in Dataproc, etc. So Jupyter is used for interactive notebooks. Then we have library called Keras. Keras is again a very famous AI/ML or machine learning library. We also have PyBrain, which is mainly used to create neural network models in machine learning. So these are some of the Python libraries which are very popular. As of this recording, we have approximately 530,000 Python libraries. The next question is, of course, how do you install Python and PIP? So Python provides installation deployment for Linux, Mac OS, Windows, Ubuntu, and other operating systems also. My operating system is Mac OS, but if your operating system is either Windows or Linux or Ubuntu, you can download from Python's official website and execute it. So what you have to do is that you have to just Google download Python. So let me show you. So I am in Google, I'll have to just write download Python. And this is the official website to download Python. So just click on it. This is basically python.org. And here you'll get the Python library for different operating systems. Because mine is a Mac operating system, so that's why it has picked up, or it is showing that download the latest version for Mac OS. If your operating system is Windows, let's say, you can download the Python version for Windows also. You can download for Linux and Unix also, or various Docker images as well. So for Windows, it will be like this, Python releases for Windows. And I am using 3.12. The latest version is 3.13, sorry. And I'm using 3.12 right now. Then there are Python sources for Linux also. These are for Linux machines, like it provides Starball and etc. So what you have to do is that you have to just click on download Python. If you want, you can use an older version also. So currently 3.14 is in pre-release, 3.13 is the stable version, and 3.12 is also the more or less stable version. So we can download any one of these versions also. So if you click on this, depending on your operating system, that particular package would be downloaded. So as you can see, Python 3.13 for Mac OS is getting downloaded. Now I can install. I just click on this particular package and Python would be automatically installed. And once installation is done, what you have to do is that you can type python -- version. It should show you the latest version. But remember one thing, Python command is not there in Python version 3. So for Python version 3, you'll have to use Python 3 -- version, and it will show you the version that has been installed. The reason that Python is working for me, because I have put an alias of Python equal to Python 3, meaning whenever I type Python, it will be interpreted as Python 3 in the terminal. So this is how you download Python. So you go to python.org and then go to the downloads and download the version that you need. Then there's something called PIP, which is Python's package manager. We need to install PIP because we download all the Python libraries using PIP only. So it can be either PIP or PIP3. So if you download Python using the python.org link, you should be getting the PIP also. So I have PIP3 installed as well. So if I type PIP3 -- version, it is compatible with Python 3.12. It means that whatever libraries I install using PIP3, those libraries would be installed for Python version 3.12.2. And these are the basic commands that you can use. The first one is Python version that I have already shown you. After the installation is done, you should check whether Python has been installed properly or not. Then either you run PIP -- version or PIP3 -- version. I have shown you PIP3 -- version, and PIP3 that I have installed is for Python version 3.12. Then you can type which Python or where is Python to find out where Python has been installed. What is the location or the installation directory or installation folder of your Python version. I can type which Python 3, and I would recommend you to type Python 3 rather than Python. So it is showing me this is where it has been installed. And I can also type where is Python 3. This is basically the binary where Python is already there. So this is the first one is the binary, and this is where the Python has been installed. You can run these commands and see where Python has been installed. Now the next thing is that we need something called IDE or Integrated Development Environment. These are needed to develop codes or programs very easily and efficiently, because these IDEs provide various advanced features like autofill, different other settings, debugging, etc. So you should always use one of the IDEs. PyCharm is one of the most famous, and so is VS Code or Visual Studio Code. you can use either PyCharm or VS Code. I have both installed, but I'll be showing you all the Python codes, or I'll be executing all the Python codes using PyCharm only. Now, how do you install PyCharm or VS Code? Obviously, you have to Google PyCharm Community Edition for Mac, or download PyCharm Community Edition for Windows or Ubuntu. So this is how you'll do it, and it will give you a link, something like this, and the link would be from jetbrains.com, and you can download it from there. So let me show you. Now this time around, I will search download PyCharm Community Edition for Mac, and this is the first link. You click on the first link. So this is PyCharm and JetBrains is the provider. First we'll see the professional. Do not download the professional edition, because to use professional edition you'll need license. So there's a trial period, I think 30 days. After 30 days it will not work anymore. So there's a community edition also. If you scroll down further, you can see that PyCharm Community Edition is also there, and you download this particular version. Now again, I'm using Mac, so that's why it is showing me the Mac image. You can download it for Windows also. So Windows exe file for professional and Windows exe file for Community Edition. Similarly, we can download it for Linux, which is a tarball for professional edition and for Community Edition also. And it provides for x86 or ARM processors. So you can download any one of those. So I will download for Mac. So click on it. So the download would start automatically. So PyCharm Community Edition is getting downloaded. So once the downloading is done, I'll have to open it and put it in the application library. Just follow the process of individual operating systems. So if you're using Windows, you'll have to keep on clicking next. If it is Mac, you'll have to put the entire folder in applications. You have to put the entire folder in applications. For Linux, you'll have to use the tarball. This is the PyCharm Community Edition that has been downloaded for me. So let me walk you through this particular IDE. So first thing is that you can open projects here. If you click on it, I already have something called Spark Hands-on opened, but I'll not use it anyway. I'll be using a different folder. This is where you'll see all the folders and we'll be writing codes, etc. Here you can see some external libraries that have been downloaded. Then you can also look at the structure. We have Python console also, and we have various Python packages if you want to install. Then you can, there are multiple services and terminal. We'll be using terminal a lot, by the way. And these are the various things that you can get. Mostly in our entire hands-on, we'll be using this particular view. We do not need structure. We'll need the project, and this is where we'll create a file, and we'll need the terminal for sure, because we'll be using the terminal a lot. Now you can actually go to PyCharm settings and set the font, appearance, etc. So I will set the Python interpreter later on, but before that you can change the appearance. So I'm using the light theme. If you want, you can use the dark theme or Darkula theme, whatever. Then you can change the font of the editor also. Currently I'm using Korean New with size 18 and weight is bold for both of them. So this is how you do the setup of your IDE. And you can also use VS Code if you want. So this is VS Code that I have downloaded. So you can download VS Code as well and run codes using Visual Studio also. So it is your choice whether you want to use VS Code or you want to use PyCharm. But for this Python course, I'll be using PyCharm to do all the hands-on. So once the download is done, we can configure PyCharm after installation. As I have shown you, you can configure the appearance, the font of the editor, etc., etc. The download would be similar for Visual Studio Code also. Now, if you want to use the command line interface, you can type either Python or Python 3 in terminal. And terminal is for all the operating systems. It can be Linux, macOS or Windows. Mine is Linux. Now type Python 3 because we are using Python. And here I can, let's say, write a code and it will show me the output. So you can use the CLI also, but of course, CLI will not give you so much of features and look and feel like the IDE will give you. And of course, if you use the IDE, the efficiency would be much better than CLI. Now, before going further, I want to talk about virtual environment because we'll be using virtual environment a lot. So we have already installed Python. Let's say this is my laptop or your laptop, or can be an EC2 instance also. And we have installed Python here. So currently my Python version is 3.12.2. Now what happens is that we can install libraries using pip, which is Python's package manager. It will be actually pip3, not pip. Let me fix this. So we'll be installing multiple libraries using pip3. So let's say we want to install PySpark because we want to run Spark code. Then we install Flask because we want to do some web development. Then we install NumPy because again we'll be writing code with, let's say, for creating machine learning models, or Boto3, which is AWS SDK for Python because we want to write some automation code, or we want to write some script to automate AWS provisioning work or something else, deployment work. Where are all these libraries being installed? So all of them are getting installed where the global Python is running. So wherever I have installed Python, that is where the libraries are getting installed. So let me show you that. I should use which Python 3. This is the place, library framework python.framework versions 3.12, where my Python is installed. Now again, for Windows it might be different. I'm showing you for Mac. For Linux also it might be different. So here I have various folders. So let's say I have folders like Python, I have folders like resources, bin, library, etc. Now what will I do? I'll go to library because that's where all the libraries are stored. Now inside of this library, if I do an LSL, there are so many folders, but there's a specific folder named the Python 3.12, which is basically the Python version that we are running. Now if I go inside of it, now inside of this library you'll find a lot of files, but we are not bothered about all the files. We are bothered about one folder named side packages, and I should be able to see side packages. So this is a folder or a directory named side packages. So let me get inside or go inside this folder. Here all the libraries are installed. These are the libraries that I am using or I have installed in my Python deployment. So let me show you. So if I type ls-l and let me see if PySpark is installed or not. So PySpark is installed. I think I had installed PyMySQL also. Let's see if NumPy is there. Okay, NumPy is not there. So let me go ahead and install NumPy. So this is how we install pip3 install y NumPy. So this is the library. Y is not needed here. So let me use this pip3 install NumPy. So NumPy is getting installed here. I can install SciPy also. So let me install matplotlib. I hope the library name is the same. Oops, sorry, the command is wrong. pip3 install matplotlib. So it is getting downloaded from the py packages, which is Python package indexes. Now if I do an ls-l and search NumPy, as you can see NumPy has been installed here. Same is the case with matplotlib also. Matplotlib has also been installed here. Now let's see whether SciPy is there or not. So I do not have SciPy. So let me install SciPy. So SciPy is getting installed. Now what would happen is that again the package would come here in the same directory. What I'm doing here, I'm installing these packages at global level. So let's type SciPy. Now you can see that SciPy has been installed in this particular directory. As you have seen that whenever I install any library, all those libraries are installed in the directory side packages, which is there in one of the folders named as Python 3.12. But let's say I have various development environment. So let's say I have 3 development environments. In one environment, people or basically engineers are writing Spark codes. And then we have DevOps engineers who are writing AWS scripts. And then we have microservices or backend developers who are writing microservices. So the Spark code would use the PySpark library, and AWS script would use Boto3 library, and microservice would use the Flask library. So as you can see, NumPy is not getting used, but it is there in the global package. So there is no machine learning coder, or there is no machine learning environment in this particular laptop or in this particular EC2 instance. So no one would be using the NumPy library. But I have installed NumPy library, SciPy library, Matplotlib, all of them in my Python environment. So all those are wastage because we do not need those libraries. So what happens here? Do we really need all libraries in the global Python location? Now it is true that all these codes will use the basic Python for sure, but do we need all these libraries that we have installed? The answer is definitely not, because NumPy is not getting used at all. So what do? We create virtual environments and associate those virtual environments to the folders or the development environment. For example, so let's say I have 3 folders in my machine. It can be an EC2 instance or Mac OS or Windows machine, does not matter. I have installed Python and PyP because that will be needed. So I have 3 folders. So one contains Spark codes, the other contains AWS scripts, and the other contains microservices. Now what will I do is I will need Spark code. So I'll need only PySpark library for in this particular folder. I'll not need anything else. So Python gives us an option to create something called a virtual environment. So what do? We create a virtual environment, and this virtual environment would be linked to the main Python that we have installed, and then we can install the needed library and use that library in our codes. Now this virtual environment would be created inside of this folder where my Spark codes are. Now same is the case with AWS scripts and microservices also. So I can create different virtual environment. So in this case, again, it will basically point to the main Python library or the main Python binary that you have installed. But the Boto3 library will be installed only in this particular folder, and then we can use the Boto3 APIs in the scripts that we run or that we code in this folder. Same is the case with microservices also. We create a separate virtual environment, and then we install Flask only in this folder or only in this development environment, and use the Flask library in all the Python codes that are there in this particular folder. So now what is the advantage? Advantage is that it can be ported to any place, meaning that you can zip this entire folder. It will contain your code, it will contain the libraries that you need along with the virtual environment. So if you can package this completely and take it to another machine. You can move it from or download it in another EC2 instance where the main Python binary is installed, and just use the virtual environment and write your code or execute your code. And it is true for all the other folders also. We can package this particular folder which contains the AWS scripts and the Boto3 library along with its virtual environment. So you can package this, put it in a zip file and port it to any other place. Same is the case here also. If you are using CLI, we need to activate virtual environment using CLI. If you are using IDE, it can be directly used in IDE. So what will I do is, I have created a folder named teenayam Python, and I'll create a virtual environment there using the IDE. Okay, so what will I do now is, I will create a new project where all our Python codes would be there. So click on File and then click on New Project. Now here I'll have to give the location of the Python project. So I have created a folder, and this is the name of the folder, teenayam_python or 3iam_python. Do you want to create a Git repository? I don't want to, because I'll not put it in Git. Do you want to create a welcome script? I don't think that is needed. Now the next thing is that, do you need a virtual environment? So we can create, or this IDE will create the virtual environment for us. We can use Conda also, or we can create a custom environment also. So what will I do? We'll be creating a virtual environment in this folder. Now let me go ahead and show you this folder first. So this is the folder 3iam underscore python and it does not have anything. This is an empty folder so far. Now I'm creating a project here and I want to create a virtual environment. The main version that it will use is Python 3, user bin Python 3. So let me try it and check what is this Python 3 version, /user/bin/python 3 version. So here we'll use /user/bin/python 3 dash dash version. So this is Python 373. This is not Python 12. So we'll not use Python 373, we'll use Python 12. Now in my case, this is where actual Python version is, which is 3.12. So I'll have to put this particular or provide this particular location, and the virtual environment will be created using this Python link or this Python library, which is version 3.12. So it is library frameworks Python framework versions 3.12/bin/python 3. Now for Windows it will be different, for Linux it will be different, for Ubuntu it might be different, but the process is more or less similar. If you are using IDE like PyCharm, you'll just have to open the folder where your Python code is. So this is the location, library frameworks python.framework versions 3.12/bin/python 3. So now I can click on create. So it says the directory is not empty. It might be the case that there are some hidden files here. There are actually, so I will remove this. Now this is mainly for Mac. You will not find this problem in Windows. Now here click on this window. I can cancel it. So let me create the project again. All right, click on create and I'll open the project in this particular window. So now the virtual environment is getting created. So as you can see, this is the virtual environment that has been created in this particular folder. Now if I go here, I should be able to see the virtual environment. So this is hidden here. But if I use the command line or terminal, as you can see, the virtual environment has been created in that folder, and the folder is 3iam underscore python. So let me do one thing. Let me create one more folder and let me show you how to create virtual environment using command line interface. So I'll be creating one more folder, 3iam-python-test, and let me get inside of this folder. And this is the command to create virtual environment, which is virtual env. It gives me error because the command is not recognizable. So the reason is that I'll have to install virtual environment separately in the command line. But we get this in the IDE by default. So in the IDE you do not have to install virtual environment separately. So it has been created. Now if I run this command again in the same folder, as you can see, the test env has been created. This is a folder, and if I get inside test env, I'll see that I do lsla, the virtual environment has been created. This is the name of the virtual environment, by the way. Test underscore env is the name of the virtual environment, and here I have this bin which contains the Python binary. Same is the case with the other one also. So if I go to my previous folder in 3iam python and do an lsla, let's go to the virtual environment, and here bin contains the Python binary, and I go inside Python binary and do an lsla. So this is the Python location. Now if you see, this is a link or a shortcut to the actual binary. So that's what I was saying. So, and Python 3 is a shortcut of Python. Python 3.12 is a shortcut of Python also, and Python is a shortcut of this location, which is actually my base Python installation. So whenever we create a virtual environment, the binary in that virtual environment or the Python binary in that virtual environment would be a shortcut of the base installation that I have done in my laptop. So that's what this diagram means. So the virtual environment that I created, the Python binary is actually a shortcut to this. It is pointing to the base Python installation. Same is the case here also. So this virtual environment is actually pointing to the base location, and this virtual environment is pointing to the same location. Now I can go ahead and install PySpark here in that particular folder, and this library would not be installed in the base location. In my case, it has been installed because I had installed it earlier. But if you have a clean installation, and if you download or install a library using virtual environment, this library will not be installed in the location where the base Python is sitting. So now you can actually zip this entire folder and port it anywhere. The final topic of this section is Python's architecture, and you'll get this question a lot, whether Python is a compiled language or an interpreted language. There's a difference between the two. Compiled language means that you'll have to compile it and generate the bytecode or the execution code, and then you use that execution code or the binary file to run your program. So in a compiled code, what happens is that you write the code in a file using some IDE and you pass it to the compiler. So there would be a separate compiler installed in your machine or wherever you are writing the code in that particular environment, and the compiler would compile this particular code and generate a binary output, and this is the executable, and whenever you want to execute the program, you will use this executable file. So this binary output is the executable version of this code. But interpreted language is not like that. Interpreted language is a little bit different, and Python is an interpreted programming language. So how does it work? We have this Python code in a file. Typically the file name is the name of the program followed by .py, and we use IDEs like PyCharm to edit this particular file. So we write the code in this particular file, and then when we press run, what happens is that it is passed to a compiler, and compiler generates a bytecode which is the executable form of this particular code. The bytecode file name is actually .pyc, and what happens is that it is passed to a Python virtual machine, and the Python virtual machine creates a machine executable code or the binary output, and then it is executed in the machine. Now it's not that we'll have to do the compilation. So we just run the code and then it is passed to the compiler. Compiler creates a bytecode of each and every line which is sent to the virtual machine, and the virtual machine creates the binary output which is then executed. And all these steps that I have mentioned is done by something called a Python interpreter. So we use Python interpreter to do all these jobs for us. We do not need to compile the code. But if we want, we can pre-compile the code. All the Python programs that we write, we can pre-compile it. And we'll revisit this in the modules topic. But if you want to pre-compile your Python code, this is the command: python-m followed by py_compile followed by your Python program name, which can be any name.py. So this is how the architecture is. And remember, by default, we do not compile the Python code. The entire code is passed through this process whenever we execute it. So whenever we press the run button or whenever we execute a Python program, we execute it using the Python code file name. So file name.py, and all these happens during runtime. So that's why Python is known as an interpreted programming language, not a compiled language per se. But if we want, we can make it a compiled language by pre-compiling the Python code. So I'll show you both pre-compilation and interpreted execution using Python. So this concludes section 1. Let's proceed to section 2, which is Python basics.